Okay, so in this problem, we're going to look at some more things that are applications accounting, and this is how many paths from A to B of length 10 are there? Well, to understand why we can use combinations on this problem, we first have to know how to do this problem. And the best way to do this is to count backwards. And that is to say, how many ways of shortest paths are there from each node? Well, if you notice on the two edges here, and we always work backwards, there's only one way from each of these nodes to get, there's only one way from each of those to get to B. So that means that when I go to this node right here, if I go down, the only way to get there is to go right. So there's one way. But if I go to the right, you can get there is one way as well. So that means I can either go down or to the right, and one way for each of those, so there are two ways. Well, that allows me to think about this node. At this node, if I go down, there's one way, but if I go to the right, there are two ways, which mean there are three total ways to get from that node to B. And do you notice how I just added 1 plus 2? Same thing over here. It's the exact same addition. I could go down to get 2 or to the right and get 1. Well, now hopefully you can see how to fill this in pretty good. If I go down from that node that I just filled in, that's going to be 3. To the right 1, that means this is 4. Down is 4, to the right is 1, that means that's 5. And so you're using, it's a recursive is the name of this that we're using, but you're just using what we already know to help us solve this problem. So at this one, if you go to the right, there are 3. Down, there's 1, so that means there are 4, which means this is 5 for the same reason, this is 6 for the same reason, and this is 7 for the same reason. Now, if I look at this next level, here if I go down, I get 3. If I go to the right, I get 3. So that means there's 6 total. This one, if I go down, I get 6. To the right, I get 4. That means there are 10. Down, I get 10. To the right, I get 5. That's 15. This one is also 10. Now I just keep going. I'll use black this time. If I go starting here, if I go down 10 to the right 10, that's 20. If I starting here down I get 5. To the right I get 10. That's 15. And then I can start looking at these. This one right here, down you get 6. To the right you get 15. That's 21. This one down, I get 15. To the right I get 20. That's 35. This one down, I get 35. To the right, I haven't done that one yet. That one should have been 35 as well. So down is 35, to the right is 35, so that's 70. This one down is 21, to the right is 35, so that's 56. This one, you go down to get 7, to the right you get 28. Add up 28 and 56 to get this one, which is 84. Add up 56 and 70 to get 126. Add these two up, and you end up with 210. So there are 210 paths in this problem. But if you notice that we used a type of calculation that's similar to a very specific type of calculation, and that's called the Pascal's triangle. Notice these numbers. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And it turns out that this pattern follows the Pascal's triangle. So the way we know this is 210 is in the, well, there are 10 units, so it's going to take 10 rows. And so it's in the 10th row, and it's in either the 4th position or the 6th position, depending on if you use the length or the width. And so you need to find out how many paths there are. You could have just said, well, what's the 4th entry in the 10th row of Pascal's triangle? Well, to do that, you use combinations. Okay? If you start with 1 and then 1, 1, if you notice, this is row 1, what we call row 1 here. Well, if I do row 2, this would be 2, 2, 0. 2, choose 0 is just 1. Yeah. And then you do 2, choose 1. Well, 2, choose 1 is 2 over 1, which would be 2. And then this is 2, choose 2, which is only one way to choose two things out of two things. And that's 1. And what it turns out to be is you can use combinations to find out the answers. So for instance, if I go back to this one, if I want to find the 10th row, 4th entry, that just equals 10, choose 4, which would be 10 times 9 times 8 times 7 times 6. Oh, no, not times 6. Over 4 times 3 times 2 times 1. 4 times 2 is 8. Cancel out your 3 here. You're left with 3. 10 times 3 is 30. Times 7 is 210. There is my answer. So you can actually use combinations to solve this problem. So if I wanted to find out how many paths of length 13 are there from A to B, well, that means it's going to be the length 13. Notice that the reason we use 13 is because the shortest distance is just 13. And then I can either use, so 13, I can either use the length or the width. It's always easier to use the shorter one. So it's going to be 13, choose 5. So the answer just is 13 times 12 times 11 times 10 times 9 over 5 times 4 times 3 times 2 times 1. You got 10 that cancels out. 4 times 3 is 12. So it just turns out to be 13 times 11 times 9, which is 1,287. So that means in this particular problem, there are 1,287 paths from A to B. This is the same thing, except your length 16. Notice how much easier it would be to find 16 choose 3 versus 16 choose 13. So the answer is just going to be 16 times 15 times 14 over 3 times 2 times 1. They're not always going to give you the length, so you're going to actually have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again, I could have used 16 choose 3 or 16 choose 13. They're both the same. Cancel this out. I get 5, 8. I end up with 40 times 14, which is 560. So there are 560 paths from A to B in this picture. The last one is this problem. This problem is tough because it's got a choke point in it. Every path has to go through that point. So all I need to do is find out how many paths from here to here, from A to C, how many paths from C to B, and I just need to multiply them together. So, and these all need to be, the total needs to be length 18, which means it's the shortest possible path. And actually it should be length 17, sorry. Well, this one, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So to go from A to C, you do 9, choose 3, which equals 9 times 8 times 7 over 3 times 2 times 1. So you get 3 times 4 times 7, which is 84. And then this one, you got 1, 2, 3, 4, 5, 1, 2, 3. So it's 8 choose 3, which equals 8 times 7 times 6 over 3 times 2 times 1. 3 times 2 cancels out with 6, so you get 56. So you end up with 84 times 56, which equals 4,704. You multiply those together because every single one of these 84 paths have to be paired with every one of those 56 paths. And you just use the fundamental theorem of counting.